Alright, so what determines what type of decay a radioisotope undergoes? Well, there are more than 1,500 different nuclei that we know about, and only 264 of those are stable and don't decay. Those are those that are in the band of stability. So we talked about this right here. That's the band of stability. And so it's all about that ratio. If you have a ratio of neutrons to protons that's in this band of stability, you're not going to decay. However, if your ratio is off, for instance, if you're on this side of the band of stability, what that means is that you have too many neutrons. So, in that case, what you would want is for a neutron to turn into a proton, if that's possible. Well, one form of decay is beta decay. Like we said, it would be emitting a beta particle, and in that case, a neutron actually turns into a proton and a beta particle. So when that happens, you lower the neutron to proton ratio because a neutron is turning into a proton. So up here on this side, you'll have your beta decay. Then down on the bottom, what's happening there is you have too many protons. Down in this region, you have too many protons. If you have too many protons, you need to get more neutrons. So if you could have a proton turn into a neutron, that'd be great. There's a couple ways of doing that. One of them is electron capture, where you pull in an electron from outside the nucleus, and basically it gets together with a proton and turns into a neutron. Or you have positron decay, which is where a proton emits a positron, which is like a positive electron, and you make a neutron. So both of those would happen below the band of stability. Once you're up above that top mark right here, that just means you're too big. And like we mentioned earlier, in that case you'll have some alpha decay going on. So the neutron to proton ratio that's too high means you're going to have beta emission, and that's where a neutron is converted into a proton and a beta particle. A neutron to proton ratio that's too low means there's too many protons, so you could have positron emission or electron capture that will make more neutrons, because a proton will be turning into a neutron. A positron, like I said, is a particle that's basically the same as an electron, but it's positive. It's a positive electron. So here are some examples of those reactions, those nuclear reactions, equations, and just kind of a summary of what's going on. This video right here is a really good one, and obviously you can't click on this because it's a video, but I have included it as the next video in this playlist. I didn't make it, but it's a really good video, so check that out. All right.